This video is intended to teach you how to solve one-step equations. First example, m minus 4 equals 9. I'm quite sure you could figure out the answer just from process of elimination. When you're solving an equation, what you want to know is what is the value of the letter. I want to know what value for m. You subtract that number by 4, you'll get a 9. And most of you will be able to figure out that it's 13. Not all questions are that easy to solve. Sometimes they involve fractions, sometimes they involve decimals. So we'll do the methods first, and then you can always come back to trial and error later. First thing you want to do in an equation is you always want to isolate the variable. Get the letter by itself. What that typically means is you want to get rid of everything beside the letter and put the letters on one side and the numbers on the other. So in this question, I want to get rid of subtracting by 4. The opposite would be to add 4, and a minus 4 and a plus 4 would cancel, leaving you with no number. But I can't just add 4 to one side of an equation without changing the value of the equation unless I also add 4 to the other side. So by including the 4 here and here, I haven't changed the value of the question. Just like on a scale, if I added a brick, that left-hand side would lower. I'd have to also add the same size and weight brick on the other side to keep the balance level. So my next line would read m equals 13. And once you get the letter isolated, you now have your solution. If you've learned this method in the past, what you may have gotten in your head is a bit of a shortcut, which I believe is perfectly acceptable to use once you understand why you're allowed to use it. Now that you see when you add 4 to both sides, it doesn't change the value of the question, perhaps you could, in the next step, move the minus 4 over and understand that once you move a number across the equal sign, it'll change its sign to the opposite. So a minus 4 on the left becomes a plus 4 on the right. And you can do the question like this. M is going to equal 9 plus 4 and get your answer of 13 that way. I find that method a lot less busy and a lot more straightforward than the one above of adding the same number to both sides. Once you see it done a few times, you can perhaps do the second method. It's a little bit less cumbersome and a little less writing. The beautiful part about solving equations is you will never have to wait for anybody to check your work to see if you're right. Here's what you can do. Rewrite your equation exactly as you were given in the beginning, except where there's an equal sign, draw a line to separate the left-hand side and the right-hand side. Then you substitute your answer into the original question, wherever that letter was. So in this case, m, I'm saying, is 13. And if I check my work, 13 minus 4 does equal 9. And therefore, I can see here that the left side equals the right side. Therefore, I've proven that my answer of m is equal to 13 is correct. You never have to wait to get it marked right or wrong. You can always check your work. Now, not all questions are like that, but they're very similar. Let me give you another one. 2 is equal to 1 minus x. Now, in this question, there's two ways to go about it. I'm going to move the 1 to the left and change it to a minus 1. So 2 take away 1 is going to equal negative x. Simplify that down, I'm going to get a 1 equals a minus x. This question is not complete because you do not want to know what minus x is. You want to know what x is. So there's two choices here as well. You can either divide or multiply both sides by negative 1. I'm going to divide, so if I divide that side by negative 1, a negative x divided by a negative 1 changes it to a plus x. Same thing on the left. Divide by a negative 1, 1 divided by negative 1 is negative 1. Your answer is going to equal overall a minus 1. You go back up to the original and do a check. Is the answer correct? 1 minus a minus 1. It becomes 1 plus 1. which gives you an answer of a 2. And of course, the left side and right side are equal. Therefore, that is the correct solution. Those are a few examples with adding and subtracting to isolate your letter. What if your letter happens to be in a different format and it's multiplied? So say 4p equals minus 20. I recommend that you do not mess with your original question. You always rewrite it. Now you ask yourself, how is the p attached to anything on the same side? Right now we have it multiplied by 4. The opposite would be to divide by 4. As long as you do the same thing to both sides, you haven't changed the value of the question. Therefore, p would equal minus 5. That is your answer. Now a little quick double check. Take your original question, plug it back in. 4 times a minus 5 gives you minus 20. Left side equals right side, therefore that solution is correct. P actually equals minus 5. Different kind of question, similar procedure. X divided by 16 equals 2. So remember, you're trying to find the value. When you divide by 16, you get a 2. You probably already know the answer. In terms of using a method for the difficult questions, building those skills, right now x is divided by 16. So the opposite would be to multiply both sides by 16. On the left-hand side, don't forget that it's really 16 over 1. So 16 divided by 16, the 16s will cancel, leaving you with just an x, which is what your goal was, to get the x by itself. And 2 times 16 is 32. And there's the solution. X equals 32. Your check would be to substitute the 32 in for the value for x. And of course, 32 divided by 16 indeed does give you a 2, so of course that's messy, but left side 2, right side 2, therefore the solution x equals 32 is correct. They can look a little bit more busy, look a little bit more complicated, but procedures don't change. You get something like this one. This one here, nice to see done and explained, because it does look a bit of like a nasty question. It's not too bad. And don't forget you're allowed to use your calculator. My original question, negative 9 over 11r equals negative 16 over 11. So right now, the coefficient in front of the r is minus 9 over 11. And it's multiplied by r. So if I take the coefficient, which is a fraction, and divide it on both sides by itself, negative 9 over 11 divided by negative 9 over 11, that would cancel, leaving me with just an r, which is what I want. On the right-hand side, perhaps if I rewrote it, not as a complex fraction, but with a division sign beside, it would be easier to see. So negative 63 over 11 divided by negative 9 over 11. When you do division, you invert and multiply. Negative 63 over 11 times 11 over negative 9. The 11s are going to cancel. Negative 63 divided by negative 9 happens to work out to a perfect number. They won't always will, but your answer, r is equal to 7. If you go back up to your original, negative 9 over 11 multiplied by 7 over 1 would indeed give you negative 63 over 11. And at this stage, you could use your calculator using your fraction button and type in negative 63 over 11 divided by negative 9 over 11. It would give you the final answer of 7. One last one. You had something like this. P divided by 7.3, and that's equal to 0.287671. Just because it's decimals does not mean the principal changes. Right now your P is divided by 7.3, so you must do the opposite and multiply both sides by 7.3 so that you can clear the fraction. When you multiply 7.3 on the top by a 7.3 on the bottom, they would cancel, leaving you just a 1, or in other words, just a p, and the product of 0.287671 by 7.3 would give you the answer. It's not very neat, 2.09999. Let's just say that's the value for p. So those examples were all of solving what we call one-step equations. The next video will cover multi-step equations.